Okay guys, so example 5 is probably the hardest in the notes. So let's just jump right in. It's deceivingly hard. It doesn't really look that bad. I think it's a no-brainer what we should let u be. U obviously needs to be 2x minus 1. That would mean du is 2dx. However, we don't have a 2 dx, so that means 1/2 du equals 1 dx. So we end up having 1/2 times the integral of x times u to the 1/2 du. Now, we run into a problem here because we have this random x, and we need it to be in terms of u. Luckily, we have an equation that relates x and u. So we can just rearrange this equation, get x by itself, and get it in terms of u. So that's what we're going to do here. We're going to add 1 to both sides. So we have 2x equals u plus 1. Divide by 2, divide by 2. So we have x equals u plus 1 divided by 2. So I have 1/2 times the integral of u plus 1 divided by 2 times u to the 1/2 du. So now I'm all ready to integrate because I'm all in terms of one variable. Now this is like u plus 1 times 1/2 because it's all over 2. So what I'm going to do is say that this is 1/4 times u plus 1 times u to the 1/2 du, just to make it a little bit simpler on myself. Now what I'm going to do is distribute the u to the 1/2 to both of these terms because I cannot integrate without doing that. So I have 1/4 times the integral. Remember, by the power rule of exponents, I have u to the 3/2 plus u to the 1/2 du. Okay, so now I need to erase because I'm running out of room. So now I'm just going to integrate both of these terms separately and multiply through by 1/4 at the very end. So I have 1/4 times, this would be u to the 3/2 plus 1 divided by the new exponent, which would be 5/2. And then plus u to the 1/2 plus 1 divided by the new exponent, which would be 3/2. And then plus c. So I have 1/4 times 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. So I've got, once I distribute the 1/4 to both of my terms with u, I have 1/10 u to the 5/2 plus 1/6 u to the 3/2 plus c. So now all that's left to do is I need to plug in my u because I need it in terms of x. So I have 1/10 times 2x minus 1 to the 5/2 plus 1/6 times 2x minus 1 to the 3/2 plus c. And that is my very long answer. Okay, moving on. Shut up. Example 6. We have sine squared 3x cosine 3x dx. Now, remember, sine squared 3x is like saying sine 3x quantity squared. Cosine 3x dx. So what we're actually going to do here is our u is going to be sine 3x. So what happens when we take the derivative of that is we have cosine 3x, but then remember about the little thing called the chain rule. Because of the inside, it's the derivative that is actually 3 cosine 3x. But then since we don't have a 3 in our integrand, we divide by 3, divide by 3. 1/3 du is cosine 3x. So we're going to plug in 1/3 du for cosine 3x dx. So we've got 1/3 u squared du, which is 1/3 times u squared plus 1 over 3 plus c. Okay, this would be 1/9 u cubed plus c. But my u is sine 3x. And to write that a little bit neater, I'm going to write sine cubed 3x. And that's where I'm going to end it for this video.